Now, what seed particles do you use? Just the same particles that we use for 2D or stereo PIV, we use for tomographic PIV. In airflows, typically we're using some kind of aerosol, which creates micron-sized particles. And for liquid flows, we're using some kind of solid particles, usually hollow glass spheres or silver-coated glass spheres. But you have to be a little bit more discerning on how much seeding you add to your flow. What is your seeding density? Tomographic PIV is sensitive to how much seeding you add to your flow. If we look at this equation here, which is the ratio of what we call ghost particles, basically particles that aren't properly found within your volume, to the number of real particles that are found. This depends on the depth of your volume in Z, your seeding density, in this case particles per megapixel, the number of cameras N that you are using, and then the size of the particle images, the area. Now, if we look at this table here where we have different Z depths and a constant particle density per megapixel, constant diameter of your images, constant number of cameras, your ratio of ghost particles to real particles increases as the depth increases. So if you want to look at a large measurement volume, you have to really be careful of not adding too many seed particles to your full field, or as you'll see later, add more cameras to your system. Now you probably can't see it in the back really well, but you can tell once you've captured your data, reconstructed your volume, you can take a Z intensity profile through that volume, and if you have a well-defined volume with sharp edges with a low background level, which is your ghost intensity level, then you can be confident that you're reconstructing the volume properly and finding the real particles that are in your flow field. Now these data are taken from some real experiments, and this is showing the effect of thickness for a constant seeding density. And in this case, it's particles per pixel. It's a little bit different scaling here. So same equation, but with this PPP is seeding density in particles per pixel. Okay. So in this case, we started off with a very thin light sheet, and these are the reconstructed volume profiles. And as you increase the thickness of your laser sheet or your measurement volume, and keeping number density constant, you can see that your background level increases with increasing distance. And this is caused by not having sufficient information to reconstruct all the particles that are in your full field. Some particles are misinterpreted as ghost particles. Basically, all the pairs aren't found properly to locate the particle within the volume. Now, considering the effect of adding more cameras to your system, this graph shows this ghost intensity level versus particle density and particles per pixel for a different number of cameras, starting up here with 2 cameras going to 8 cameras. And you can see easily from, and this comes directly from this equation here, you can see easily that if you have a stereo system, it's pretty difficult to make any type of volume measurement using any sort of reasonable seeding density. By adding a third camera in the red here, we can look at somewhat reasonable seeding density with 3 cameras, but you are definitely limited once you get up to seeing density, the levels of 0.01 particles per pixel, then you start your ghost level starts to become too high. The common configuration with 4 cameras is shown in the green here, and typically we're operating at a point around 0.05 particles per pixel. Now, if you're fortunate enough to have 8 cameras, or even 6, you can push this seeding density level up, just simply because you have more sensors and more information to record all the particles that are illuminated by the laser. Now, one thing that's important to note too, in terms of number of cameras, the format of the camera is also important. The more pixels you have on your camera, the more information you can store on that array. So it's not simply just the number of cameras, but also how many pixels you have to